Hi, let's figure out how to calculate the unknown side of a right angle triangle by using sine, cos, tan, in other words, the trigonometric ratios. First of all, let's set our calculator to degrees and not radians. So we do this, we're going to turn our calculator on. So we can see that this calculator is set to degrees because there's a little d there. If it wasn't set to degrees, it would look like that. So if you have a little r in the corner, then you have to change it to degrees by going shift, setup, let's look for degrees. So that's number 3. So click number 3 and it will change it back to degrees. That's what we want. Now different calculators might look a little bit different, but essentially they all have a little d and a little r somewhere, and most of the time you just have to click mode or setup and look for DEG for degree or D. Let's have a little bit of practice using the calculator. So here we have sine 25. You don't have to close the bracket. It gives you that. Cos 25 is over here, 0.9063. Tan 39 is over here. And notice that I'm not closing the bracket. You don't have to unless you're multiplying the whole thing by something else. Sine 30 is over here. So have a go with me and see if you're getting the same numbers. If you're not getting the same numbers, then you probably have it in radians and you have to change to degrees. Now 0.5, or if you want to change it to decimal, so this is the decimal fraction button, you can click that. So 0.5, since we're working with decimals, that's what we're keeping with. Next one, cos 60. Now remember what we said last lesson about cos 60 and sine 30? Now cos is the complement of sine. So when they add up to 90. So if cos is 60 and sine is 30, then we have the same answer. And then lastly, tan 45 as a practice. And we have 1. Now have a little think about why tan 45 is equal to 1. The clue is in the previous video. Now that we know how to use the calculator, let's solve some problems. Use trigonometric ratios to solve for x corrected to decimal places. I would usually circle or underline 2 decimal places because I don't want to lose that half a mark when I get to the answer. So let's have a look at this triangle. What was step number 1? Step number 1 is to label it. So across from 90 degrees, we have the longest side, the hypotenuse, next to the angle we have A adjacent, and lastly opposite. What was step number 2 from a previous video? We have to figure out whether we use sine, cos, or tan. Let's have a look. We have O and A with information, or in other words, we're going to use TOA, tan. So let's write that out. Tan, the angle, so tan 42 is equal to opposite over adjacent, or in other words, x over 11. To get x by itself, what do we need to do? We have to find the inverse of dividing by 11, which is timesing by 11 on the other side. So 11 times 10, 42. 11, and know that when you times, you don't have to put times in between. It will times automatically when you put 2 things next to each other. So 11 times 10, 42 equals 9.9044. Have we finished? Not quite. We have to chop it to 2 decimal places. So we have to chop it off up there. So you have to keep the 0. So 9.90, and the units is centimeters. Don't forget units. Don't forget the decimals. One more question. Pause the video and see if you can solve it yourself, and then unpause to check the answers. Step number 1, label it H, A, and O. Step number 2, think SOHCAHTOA or TOA. We have O and H, so it's going to be this one here, sine. So sine 29 is equal to opposite 9 over hypotenuse, x. Now we have to move the x by itself, but it's at the bottom. So we're going to move it to the other side first. So inverse of dividing by x is timesing by x. And now we have this chunk over here, something times this thing. So the opposite or the inverse of timesing this thing is dividing by that thing. So we're going to move that over the other side. So 9 divided by that thing. So now x equals to 9 over sine 29. Let's get our calculator out. So clear everything on button. We have 9 divided by, now this is going to be long one, so I'm just going to put a bracket just in case. Sine 29 equals 18.56. It doesn't say in the question because I forgot to write the question, but that's 2 decimal points. If it was 1 decimal point, then it will be 18.6. If the question doesn't give you how many decimal points, a good idea is to look at the values they've given to you and use that number of decimal points. So here we have here we have no decimal points at all. You can always give 1 extra, it doesn't hurt. So you can just leave it as 18.6. But otherwise, 0 decimal points will be 19. So this question was a little bit different to the other one because x was at the bottom. Let's compare these 2 types of questions side by side so we can remember how to solve them. Give this a go, pause and unpause when you're ready to see solutions. Step number 1, label O, A and H for both triangles. I won't go through it, you should know it by now. Step number 2, think so, ka, toa. Here we have AH, so that is over here, cos. Over there we have O and H, so or sine. So cos for the pink one, sine for the blue one. And cos of A over H. So O over H, so 3 over X. We can see that X is at the top over here and X is at the bottom over there. That one's an annoying one, so let's work that out. Move the X over and move that chunk back underneath the 3 and then solve using a calculator. Whereas over here, pretty straightforward, bring the 5 across and then plug it into the calculator straight away. So it's 1 less line. So now we get X equals 4.9384. It doesn't specify how many decimal points, so let's not worry about that now. Okay, so the point of putting these 2 side by side was to double check where the X is. If it's at the top, then the working out is a lot faster because we can see that it's just 1 step and into the calculator. Whereas when the X is at the bottom, make sure that you move the whole chunk underneath the 3 and work that out using a calculator afterwards. So be very careful where X is, but the steps are the same. 1, label. 2 is a SOHCAHTOA. 3, then rearrange to get X. Let's see a problem solving type question. Ash hikes north 70 degrees east or 70 degrees true bearings for 5 kilometers. How far east from the starting point has he traveled? How far north from the starting point has he traveled? That north 70 degrees east or 70 degrees true bearing is the same direction. So we start straight up for north or true bearings, and east is going that way, so that way. So the angle we're working with is from here to here. It's important to label it, but sometimes students forget and label that other angle. So make sure you're following the instructions very carefully. So we have to draw that line, and afterwards we can complete it by drawing a right angle triangle. It doesn't matter if you draw upwards or across, because if you use it working out, you're going to get the same answers. So here we have, let's label the horizontal X like the X-axis, and let's label the vertical Y. It's always a good idea to label this way Y and that way X, so we get less confused. So we're looking for east, that's going to be our X, and north is going to be our Y. So 5 kilometers is how much he's traveled, so that darker line there. And now how do we figure that out? We'll do it one at a time. So first of all, label, that's going to be H, the angle's there, so that's going to be A, and the opposite side is O. Step number 2, which one are we going to work with first? Let's figure out SOHCAHTOA. If we're looking for Y, that's A, and we have H, that's going to be cos. If we're looking for X, we have O, and we have the 5, so that's going to be sine. So cos 70 equals adjacent over hypotenuse, so cut. Then for X, it's different because it's sine 70 and it's opposite X over 5. Now bring the 5 over, we have Y is equal to 1.71 kilometers, whereas over there, bring the 5 over, we have 5 sine 70 and X is equal to 4.7. And a way to check this is, all right, X is that measurement there, 4.7. y is that measurement there, 1.7. So that's about a little bit less than 5, and this is a little bit less than 2. And check that these two measurements are both smaller than the hypotenuse, because the hypotenuse is the longest side. And is it? Yes, they're both smaller. Another way to check is roughly the triangle looks like O is going to be longer than Y. And yes, our O is longer than a Y. So little things to look out for so you know what's going on and double check, not just plugging in numbers. Okay, that's it from me today. So remember a couple things. Practice with the calculator. Go back to the first screen, plug the numbers in, get really quick at using and finding all those buttons. It's not hard, it just takes a little bit of practice so you don't forget where to find things, especially in the test when you have a little bit stressed. Be careful when X is at the top, then it's a simple multiplication. But if X is at the bottom, then don't forget to bring it over, bring the chunk underneath the other value, and then divide. So be careful with those too. And units, decimals as per usual. Thanks for watching. We're going to look for, so we've looked for sides. What do you think we're going to look for next? In the next video, we're going to look for angles. Okay, see ya.